Welcome friends, I am Dr. Vivek Kumar Rastogi, Associate Professor, PSIT Kanpur. I am here to teach you the topic on the subject of antenna and wave propagation, the basics of antenna. So, starting with the basics of antenna, here is the content. First, the learning outcome, then introduction to antenna, radiation mechanism and types of antenna. Starting with learning outcome, because it is necessary that what is the student going to take or going to achieve from this topic. First, the student will able to learn basic definition of antenna and the concept of antenna. The student will able to recognize different type of antenna. Then they will able to understand the radiation mechanism through air and space, free space. Then the student will be able to recognize the difference between 2D and 3D pattern. Basically 2D pattern is also known as polar plot. So, through this topic student will able to understand basics definitions, types of antenna, radiation pattern mechanism and how antenna radiate in free space. So, let us start with introduction of antenna. What is an antenna? Antenna is basically nothing but is usually a metallic device for radiating or receiving radio waves. Earlier in 1994 and before that in 1886, Heinrich Hertz, the scientist name which invented the dipole antenna. So, this definition coming from that scenario, a metallic device, but later on as the IEEE standardization is happening, the definition is going to be changed. The antenna is a device which means for radiating or receiving radio waves. It is neither be important that it must be metallic. So, earlier the differences came, it is started with metallic concept and now later on it goes as a dielectric. So, there is a difference between metallic and dielectric semiconductors devices. So, as this course is progresses, we can differentiate the metallic and dielectric and other substrate which is available. So, in other words, it is a transition device or transition structure between free space and a guiding device. Let discuss with proper proposition by means of figure. So, here if you visualize, antenna is nothing but a device which is connected to source. Here we have guided the source connection and source is nothing but voltage waveform or current waveform, whatever is required as per application demanding. So, here we considering electric field or voltage source. So, what happening as the sinusoidal voltage progresses through in this transition. Now, in this transition from here to here, it is a transmission line. Transmission line, it may be made of metallic device, waveguide, coaxial cable and other means. So, it is nothing but guiding device which guide the source voltage from this end to that end where antenna is connected. So, this is our antenna section. So, as soon as the voltage waveform approaches towards this antenna section, now this because of tapered distribution of antenna, it is not a straight line, because once we are completing this topic, we have to clear understand what is required to made of antenna and how radiation mechanism is built up, because a straight line is nothing but a good conductor. Good conductor means guiding energy from one port to another port. So, that is termed as transmission line, and other than we have include here antenna, and then later on we have see that radiation free space wave. It is generally 3-dimensional wave and we are here showing a plane wave, but clearly we differentiate between 3D and 2D later on. So, this antenna is tapered transition, because some discontinuity is required to create disturbance in acceleration of charges. Acceleration of charges means this voltage disturb the structure of conduction structure of this metallic device and some types of electron start vibrating and thus oscillation of charge particle, and this charge particle create disturbance, and this disturbance is nothing but leakage of radiation in free space. because as you seen that this is a open circuit condition, and we know that open circuit condition the voltage is or potential is high and current is low. So, same alternate scenario for receiving side. So, this is the transition for transmitting side, and same scenario this wavefront travel in free space and arrive to the same structure of antenna connected to the source again, and this transition again is built up like this, and orientation may be changing depending upon sinusoidal nature of antenna, voltage source applied here, and again we found this type of arrangement, and now here we have short circuit condition, and again the basic concept from the network that short circuit condition is nothing but voltage is 0, potential is minimized and current is high. So, this is the basic condition or basic requirement for a transmission as well as receiver antenna condition. So, moving to the next slide. Introduction to antenna. Here what we have doing this, earlier we have divided by means of circuit condition. Now, with the help of two port network we further categorize our antenna source side, transmission line, antenna. So, source is nothing but made of voltage source Vg as we taken earlier. So, here is the impedance Zg at the source side. Here is the transmission line, this is the transmission line. It may be built up from waveguide, it may be form of 2-wire coaxial cable and any other form which we require. So, this is transmission. So, again the basic definition, it is a transition structure which guide from source and deliver the energy to antenna, and from antenna side due to mismatch of this radiation or impedance the radiation start leaking into free space. So, this is the Thevenin equivalent of antenna in transmitting mode. Up to this part here RL represent the loss resistance due to conduction and dielectric losses, because this antenna as well as transmission line built up of some conductor, dielectric may be used. So, they have inherent properties of losses, we cannot completely minimize this, there must be something value. So, due to this there is a mismatch between two resistance value. Next, RR is the radiation resistance, and it is the most important resistance which require for radiation to happen. So, if you comprise this ZA, this total is nothing but ZA, and we have here represented ZA is nothing but RR plus RR plus reactance part JXA. So, this is ZA, this is ZZ. So, for maximum power transfer condition this RR or overall if we are considering ZA must be perfectly matched, but most of the condition it is not possible due to the open space condition which is termed as free space as well as inherent properties of material itself. So, what happening, there is a slight mismatch between these two values, and this mismatch lead to the leakage of energy in terms of electromagnetic wave. Now, it must be possible that the source is travelling toward the antenna side, but due to mismatch there is some reflection also happen. So, this reflection again goes back to in this direction, but most of the cases we need to protect that it never go or reach to this Vg side. So, we require attenuator some type of circuit for basic application. So, this is for basic condition, we do not shown you here any attenuator. Okay. So, at some time it will create constructive as well as destructive interferences of to and fro signal, and hence termed as standing wave, and we are discussing in terms of voltage. So, it may be summarized as voltage standing wave ratio, which is another characteristics or fundamental property of antenna. Okay. So, through this there is a mismatch and this mismatch result to the leakage of energy in free space, as well as some portion is reflected back toward the source side, which hindrance or create constructive as well as destructive interferences. So, this is the basic Thevenin equivalent of antenna in transmitting, same as we can discuss in receiving side. Now, the most important, how the radiation happening, radiation mechanism. Before going to this topic, first understand the basic Maxwell equation, what it tells. A moving or time varying electric field can give rise to time varying magnetic field, and a time varying or moving electric field give rise to time varying magnetic field. So, this concept must be remembered, because once there is electric field and with time it will vary, there is a generation of magnetic field, and thus together electromagnetic wave generation, which is termed as EM wave, electromagnetic wave. Okay. So, how it is happening? Initially what we have said, oscillation of charged particle, and how it happening? Due to applied sinusoidal voltage. So, all radiation is caused by accelerating charged particle, though there are several other conditions or necessary condition radiation, we discuss it later on. So, all radiation is caused by accelerating charges, which produces time varying electric field, and as per this law of Maxwell, time varying electric field will give rise to the time varying magnetic field. So, this way the concept of generation of electromagnetic wave happening, but most important thing is that electric and magnetic wave E and H field is nothing but out of phase by 90 degree. So, if we are discussing this is the E field, then H field must be out of phase by 90 degree. So, in 2D this is H field, this is E field, it is perfectly separated by 90 degree phase shift. So, this way you remember the generation of electromagnetic wave, which is the radiation governed by antenna. Okay. Now, for example, let us discuss with how antenna radiate. So, first there is some basic mechanism, because we have considering this wire. Suppose this is made of metal, this wire is made of metal having finite length L, and now what happening, as the source we have provided over this side, it start flowing toward this end. So, what happening, at starting it is short circuit case, and at the end it is open circuit case. From here it cannot move further. So, the potential or voltage is maximum at the end of this wire, though the current is maximum at the center. So, this concept can be easily understand. If this is my wire length having L length, so here and here voltage is maximum and the current is maximum over here and decaying at the both ends. So, this way voltage and current differentiate, and that is the concept of electromagnetic generation E and H field. So, from here if you have seen that equation 1.3, L d I by dt, Z is suffixed because we assuming that Z is the direction of propagation. L d I Z dt is equal to L q E dV by dt. So, length into time varying current is equal to nothing but length into the charge which is included in this wire length into the acceleration difference dV Z by dt. Okay. So, this way this is the basic radiation condition equation. If you see in this 1.3 equation, L d I Z dt is equal to L q L, q is the charge dV Z by dt and V is the acceleration, velocity of acceleration of that charge particle. So, from here we can clearly say that it is mandatory to create radiation, there must be time varying current. If there is a constant DC, there is no radiation. There must be some time varying current or time varying voltage, and second part acceleration or deceleration of charge. a uniform flow will not result into radiation. There must be some disturbance in velocity of charge, so that they will change their acceleration. And how it happened? If we build some structure which is not a straight one, that is called discontinuity. And if you remember the figure 1.1, there is triple transition, and again to this point it must be required some disturbance, so that this charge acceleration and deceleration may be changed. So, this is the basic radiation mechanism for a wire, and wire is nothing but best example of dipole antenna. Now, in next slide, rather than this isolation, there are some other condition to produce radiation mechanism. So, we discuss one by one. If charge is not moving, suppose if charge is not moving and current is not created, there is no radiation. Again initial condition, if charge is not moving at all and there is no time varying current and voltage, there is no radiation at all. Now, if charge is moving with uniform velocity, earlier what we said, there is acceleration and deceleration, but we say that uniform velocity does not create radiation until unless if there is some type of discontinuity in the wire. If wire is straight, there is no radiation until there is a uniform with uniform velocity, but with uniform velocity there is some disturbance in the structure, like tapered one, like discontinuity, like circle or any other shape which you assume, because antenna made of any shape, it is not bounded by shape. So, if charge is uniform velocity and there is disturbance in the structure of antenna, there must be radiation. And last, if the charge is oscillating in time domain, if the wire is a straight one, there must be radiation. That is the third point, acceleration and deceleration. If charge is oscillating, there must be radiation. So, remember this 3 point. If wire is straight, uniform velocity, no radiation. If charge is not moving, no radiation. If charge is oscillating in free space or in a bounded media, there must be radiation even if wire is straight, even if wire is straight. So, here is the structure that is termed as curved structure. It is not a straight one, there is discontinuity. So, again radiation. Next possibility, bent. Again it is straighter one and now it is bent by some angle. So, there is discontinuity and again there is a radiation. Next, discontinuous structure, the radius can be varied, again there is a radiation, and terminated by means of load, there is a radiation. So, please remember this concept of necessary condition of antenna radiation. Once again I am explaining this, if current or charge is not moving, there is no radiation, charge must be accelerated, this is the basic requirement. If this charge is oscillating in time domain, so time varying charge create current as well as voltage. So, vice versa E and electric field create, so electromagnetic radiation happen. So, and if wire is straight, even there is a radiation because of this oscillation of charge particle, but if there is a discontinuity like this and charge is moving with uniform velocity, there must be radiation. So, this is the basic 3 condition to have radiation in antenna. Now, I am giving the basic example to understand this with, suppose I have a charged particle, let it is electron, negative charge particle I am showing, let it is an electron and it is situated in free space. Free space means this space, and suppose there is a free electron in space. So, earlier it is situating like this and there is no disturbance. Now, suppose someone or some other charged particle came it with some velocity and hit it hard. So, what happened? When you hit it hard, it required or gain velocity, acceleration. Now, what happened? Earlier the disturbance which is shown here, the inner region, blue region, and this outer region is the region where disturbance occupied more, and this region is nothing but antenna field region, which we discuss later on. This is far field, this is near field. So, this way we can understand. So, what happened? It gains some velocity. So, it start accelerating. So, acceleration it gain, there is a more disturbance, and again it is our nature or human tendency to fix up the initial position. So, what it require? It generate same amount of force to pause down, but it not happening. Okay. So, there is a leakage of electromagnetic field, because time varying charge create time varying current, and time varying current generate or give rise to magnetic field, and this according to Maxwell equation, time varying magnetic field give rise to time varying electric field and vice versa. So, there is a need of electromagnetic wave generation, and it is discussed by this. Now, I am give you simple example how a dipole antenna will radiate. See, the polarity is changing, plus minus plus minus plus minus. So, what happening at the end of this wire, the detachment of radiation pattern is happening, though this detachment is required perfect length, which is generally half wavelength or quarter wavelength we discuss, but most of cases is lambda by 2 dipole antenna, and which is lambda is nothing but wavelength, and wavelength is nothing but relation between frequency and free speed light, light which is speed of light, which is 3 into 10 to power 8 meter per second. So, this is the general or normal radiation pattern which is happening. Okay. Now, how the receiver antenna radiate? This is the transmittant side, it start radiating. Dipole antenna is connected with source, it start radiating, but this receiver antenna is placed far away from the dipole antenna or transmitting antenna. So, what happening? There is a distance factor. Now, this leakage need to be traveled down and reach up to receiver side, and most importantly, remember my friends, this amount of energy which is detached from this source side is never going to be reached totally towards the receiver side. There must be some losses, which is known as free space loss. Okay. So, a portion of that power, a portion of that transmitted power is received by this antenna, and again we earlier give this concept to you, that is voltage is maximum at the opening end of dipole antenna, and current is maximum at the center of dipole antenna. Remember this figure? For positive half cycle, and current scenario is this one, this is voltage. Next cycle you can assume like this voltage waveform, and current waveform is changing like this only. So, this way we can clearly understand a portion of some power is intercepted or received by receiver antenna. Here the transmitting and receiving antenna are identical, both are dipole antenna, but in case to case depending upon application you can change this. You may use horn antenna as a transmitting and dipole antenna as a receiving. So, it is your choice, and most importantly it is not choice, it is depend upon applications part. So, what we required. Okay. So, this is the basic example how antenna radiate. Next, the last topic of this lecture, the types of antenna. As we earlier stated, the wire antenna, class of dipole antenna. So, there are different types of antenna, if you see that, end fire, loop, dipole, stub, slots, apertures. There are numbers of different types of antenna possible nowadays. These are limited theory, but most researcher right now are developing fractal antenna is the case, leaf antenna is the case. So, it is not mentioned over here, you need to learn these things. This is the last 5-year technology. Okay. So, if you find end fire, it may be different types of end fire is nothing but wire antenna, types of wire antenna, and it may be dipole, helix, Yagi-Uda, log periodical and conical. Yagi-Uda antenna, if you remember the antenna which is look like this, Yagi-Uda antenna, the most ancient or most used for television applications. Okay. So, Next, dipole type, it may be folded dipole, twin wires, long wire, rhombic, beverage, biconical, it is all part of syllabus. So, as the syllabus progresses, we discuss one by one about these types. Now, there are different types of antenna known as slot antenna. Slot antenna can be used as a microstrip antenna in microstrip slot antenna termed. Now, there is a patches and it may be form of arrays. Number of slot assigned in a predefined area create array of antenna. Okay. And there is one more, aperture type. Aperture type is nothing but dish antenna, reflector types of antenna, okay. Parabolic, corner, flat, random, FFS, horn, and most of antenna. It depends what you design, it can be create an antenna. So, there is no boundation of shape at all. Okay. By means of picture, I can show you some types of antenna. Helical antenna, dipole antenna, as we discussed earlier, it is a wire antenna. Okay. Horn antenna, this is reflector type of antenna and it is known as parabolic reflector. Okay. Next, this is loop antenna, closed loop, it is circular one, you can make a square one also. Okay. It is not necessary that you always make circular one. This is also a square one loop antenna. This is monopole antenna, single wire antenna. Okay. This is example of antenna array of dipole. You can see that this is structure, this is nothing but dipole. So, Yagi-Uda antenna, and here is arrays of antenna of helical one. This structure is helical antenna and here we use 4 helix. So, it is nothing but 4 identical types of helix. So, it is termed as array of antenna. Here are some more picture. Here we can see the rectangular microstrip patch antenna. So, this is type of patch antenna. What happening? We are require some type of dielectric substrate over which we etch conductor. It is made of copper, aluminum, whatever we require. So, generally made of conductor which is copper. So, copper is the good conductor. So, a portion of copper is etched and rest is removed to form a patch, and same as beneath the substrate there is a ground. Okay. So, patch, dielectric, we can 2D diagram from here, we can see that this is the dielectric substrate having dielectric constant epsilon r. Over here we have patch, metallic patch, and over here we have ground which is again conducting ground. So, this type of structure is known as microstrip antenna, very important antenna. Most of the mobile phone utilize this type of antenna. Nowadays, it is printed type of antenna, okay. And this is slotted waveguide array. These are different slot each from the or removed from the waveguide. So, it is termed as slotted waveguide antenna. So, in today's lecture, we discuss first the basic definition of antenna, as we seen that it is not necessary need to be metallic one, even dielectric can resonate. So, remember, good transmission line is nothing but poor form of antenna. Good transmission line which is guiding source towards destination, the energy is guided between this transmission line, which is poor form of antenna, because there is no possibility of leak the charge or electromagnetic wave. So, it termed as poor radiator, and good resonator, it is other condition which we discuss later on. So, transmission line is a poor form of antenna, and leakage of charge particle required acceleration or deceleration of charge, or time varying current create time varying current create time varying magnetic field, and vice versa, time varying magnetic field create time varying electric field, hence electromagnetic wave. Second, we discuss about radiation mechanism, how radiation is happening, we discussed in briefly the condition of necessary condition of radiation mechanism. Then and last we discuss the types of antenna. So, this is the all about the basics of antenna, because it required to understand this basic definition of antenna, how it will radiate, what is the different types of antenna, to initiate our syllabus in deeply through next lecture. Okay. Thank you.